Okay, so in example 1, AC and EB are diameters of circle R. It says identify each arc as a major arc, minor arc, or semicircle of the circle, and then define its measure. So let's start with EA. So there's two ways to look at EA. You can either go E to A this way, or you can go E all the way around the circle this way. So how do we know if they meant the yellow arc or the green arc when they just give us the two letters? Well, what we didn't say back up in the last video, but that I need to add now, is that the minor arc is usually the only one that uses two letters. It's not wrong to use three letters. It's not going to hurt anything, but if you want to name a semicircle, like semicircle she, or semicircle or major arc U, you have to use three letters. You cannot just use two letters if you want to name a semicircle or if you want to name a major arc, because otherwise, just like we just saw, you won't know which way around to go around the circle. But two letters is always a minor arc. So first of all, this is a minor arc. And then find its measure. So there's a couple of different strategies we can use for this. To me, the easiest strategy is to look at the fact that this is a line right here and all lines are 180 degrees. So we have it's not really a linear pair, it's a linear triple, I guess, but all three of these angles would have to add up to 180. So 180 minus 100 minus 30 would leave me with 50. Now, another strategy would have been to use the vertical angles, and there's even other strategies, but 50 degrees for that first one. Okay, same picture, all new scenario. This time we're go in the order of the letters. Make sure you always go in the order of the letters, D to the E to the B, and you don't necessarily have to go clockwise or counterclockwise. It's just the order of whatever the letters are. That's the order you go around the circle. Okay, and so this one, it looks like, is more than halfway around the circle. It's more than 180 degrees. We would call this a major arc. And then they want to know how many degrees all of this is. Now, this is one of those scenarios where I think the cheater's trick is faster, where you can just say 360 minus this minor arc minus the green arc, because we know that the green arc is 150 and we know that it's 360 all the way around the circle. So let's take the whole minus the green part, and so we get 210 for arc DEB. And remember, the M out in front stands for the measure of something, is what that means. All right, so pause the video, you try AB, and then we'll come back and take a look at it. So first of all, without even looking at the picture, I knew it was a minor arc right off the bat because they only gave me two letters, and that only happens with a minor arc. Then second of all, I have to find the degrees. Again, I used my linear pair. This is a straight line, so it's 180 degrees minus that 50, give me 30 degrees for the minor. 130 degrees for the minor arc, AB. All right, let's look at some more stuff with adjacent arcs. Two arcs are congruent if and only if their corresponding central angles are congruent. So what the snot does that mean? Well, here I have arc he and arc it. And I can say that arc he and arc it are congruent. And the reason why I can say that is because this is 90 degrees here, meaning this arc is 90 degrees, and this angle, I think I said angle arc a minute ago, this angle is 90 degrees, this angle is 90 degrees, and so their matchy-matchy arcs are 90 degrees, their corresponding arcs, therefore they will be congruent. So if the angles are the same amount, the arcs will be congruent as well. And then we also have the arc addition postulate. This is part plus part equals whole for arcs. So it says the measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. So we're just saying TW plus WO adds up to the whole thing, TWO. So like, for example, let's put some numbers on here. If this is 100 and this is 50, then the whole thing from T to the W to the O would be 150. Okay, and then the last example, we know that PR and QT are diameters of circle A, and then we've got some degrees marked on, some central angles marked on our picture, and that's really kind of all we have to go on. So first of all, we know if this is a diameter, PR is a diameter, it's going to cut the circle exactly in half. So this half. And then we also know that QT is a diameter, so it would be 180 degrees as well. And that's on either side of that diameter. So it's both on this side and on this side. So just something to keep that in mind when they tell you something about a diameter. All right, so here we go. We've got U to the P to the Q. So U to the P to the Q. And so we have 40 plus the 90 for the central angle, so that one is 130. The next one is P to the Q to the R. P in the order that the letters happen, P to the Q to the R. So that one, since it's exactly a straight line all the way across, it's a diameter. Remember, it does have to go through the center of the circle to be a diameter, would be 180 degrees. That's a semicircle. And then if you'll pause the video and you try. So R to the S to the U. You knew the 50. You know what? The easiest way to do this maybe would be to do the whole 180 and then just subtract out this 40 here that you didn't need. So 180 minus that 40 leaves me with 140. That's probably the fastest way to find R to the S to the U. However, there are other ways you could do it. You would also know that this was 90 because it's a linear pair with this 90, so this has to be 50, and then you could add up 50 plus 40 plus 50. I mean, you can also use the fact that there's 360 degrees in the circle. This is what is so fun about circles, is that there's like several different ways to work every problem.